everyone. How is everyone doing today? Good. I'm really honored to be here. My name is Sarah Followill. I'm an undergraduate student at the University of North Carolina, Chapel Hill. And this is my presentation, Geovisualizing Urban Sprawl in the Atlanta metro area. So a little bit of context about me and my project. I'm an environmental studies major at UNC. I'm working towards GIS and studio art minors. Right now I'll graduate in the spring, so I'm pretty much almost done with that, which is a little crazy to think about. I'm primarily interested in sustainable architecture, but also urban planning, green infrastructure, and land use. So this project kind of lends itself to a mix of those things. The project itself was created during a class that I took last semester. It was Geog 456 called Geovisualizing Change with Dr. Javier Arque-Nazario. And in this class, it was primarily a coding-based class that had GIS elements to it. We were instructed to pick a topic at the beginning of the semester that we were interested in, and then we would learn coding techniques throughout the semester and apply data from our topics of interest to the coding elements that we were learning, and kind of creating small mini projects with our data and adding more data to that project along the way, and finally culminating in a final project of our topic of interest. So this project that I'll be telling you about was my term project for the semester on urbanization in Atlanta, my hometown, and it ended up being the UNC Chapel Hill GIS Map Day winner for 2022, which was a competition that I competed in last year. So a little bit more background. Atlanta, Georgia, which is my area of focus, is my hometown, and I lived there for 18 years until I started at UNC Chapel Hill. It's an amazing city, I love it, but it has really grown a lot in the past decade, and some of that has been positive, but a lot of that has been in the form of urban sprawl, which some of you may be familiar with, but it is primarily characterized by a trend of populations moving towards the outer parts of the city, not as much in the city center. So we're losing some of that density in the city centers and gaining some density in total population in the outer parts of the city, kind of more of the suburbs. That is also characterized by autocentrism, so because everything is really spread out, people have to use individual vehicles like cars to get places. And that's something that I experienced firsthand living in Atlanta. Pretty much anytime you want to go somewhere, you have to get into a car and drive. It's really not walkable at all, not bikeable. I grew up in a family that really loved to bike, but there's not really many places that you can just leave your driveway and bike to. You have to go somewhere and bike if you want to do that. There are some green spaces, but that's dwindling as more people are moving into Atlanta, more apartment high-rises are going up. It's just, it's a growing city, but it's also sprawling. And so this urban sprawl also disrupts ecosystems. So as this built environment is expanding, we're covering up areas that were previously covered with vegetation, like grass, trees. Atlanta is an extremely forested city, if you've ever been there. Tons of trees around, it's beautiful, but a lot of those trees are being taken down to account for this growing sprawl. Additionally, there's something that some of you might be familiar with called the urban heat island effect, and that is when you're paving over all of these areas that were previously covered by grass and dirt and vegetation, and when you do that, the sun's rays hit that concrete, hit that pavement, and are reflected into the atmosphere instead of being absorbed as grass or soil would do, and those sun rays that are reflected are trapped in the ozone and leading to rising urban temperatures. So if you look at different temperatures across the US, you'll see that there are hot spots in these urban areas, so the urban heat island effect is creating that phenomenon. Additionally, it's a problem for hydrology. When you pave all these areas, we're also covering up grass and dirt that would previously absorb water as well as the sun's rays. And instead, that water is going onto pavement, it's going onto sidewalks, and is gathering pollutants that might be on those sidewalks, gathering trash, oil from cars, and is taking that either into sewers or local waterways, which is not good for hydrology. Additionally, in an autocentric area, you have vehicle emissions, polluting the air with more CO2. If more people have to use cars, you're going to have more carbon in the atmosphere. So with this population becoming less dense in the city centers, moving outside, you have all of these aspects of urban sprawl. So a program that I've been inspired by and have used in the past is called Social Explorer. It's a database resource with 220 plus years of data from the decennial censuses and also American community surveys. It looks a bit like this. Here on the top, you can choose a topic such as population density and zoom into any area of the US and see chloropleth maps, so like this one pictured up here, of population density in your chosen area or whatever topic you choose. There's certain years that it has data from. This one I believe is from 2021 in the top. But where Social Explorer lacks is it doesn't really do a great job of showing change over time. So I was really interested in seeing how the built environment of Atlanta has changed over time and how that correlates to population density data. So this is 1 year. You can change the year, but it doesn't do a great job of creating a way for users to see the data physically changing over a period of years. So I wanted to create a visualization that would allow the user to manipulate that data more easily and see the actual change. They do have a feature that you can see like percent change in a certain topic over a period of years, shown in the bottom here. Like these are population density census tracts in and around Atlanta and their percent change over the course of, I believe, 5 years. However, again, this doesn't allow the user to actually interact with that data. And another aspect that I was interested in and wanted to combine into my geovisualization was satellite data, raster data. This is something that we learned about in my class using Google Earth Engine to access remotely sensed images of different areas. And I really wanted to look at how, when you see the built environment, see this gray area over on the image to the right, in amongst the vegetation, how is that physically expanding over the period of years that I wanted to study, which is the past decade? So that physical expansion, how does that correlate to the population density data? Are we seeing a rise in urban area in and amongst the population moving out of the city centers and into the suburbs? So I wanted to see if there was a correlation with that. In obtaining and cleaning my data for the vector population density map, I downloaded American Community Survey population density data for select census tracts. I created a CSV file with the selected census tracts that I wanted to study in and around Atlanta, and downloaded data for population density in those census tracts in a period of years from 2010 to 2019. This was very tedious. The data was not very pretty. It looked kind of like, you can't see very well, but up there in the top right corner, it was horizontal. The names of the census tracts were way too long. They weren't matching my shapefile that I wanted to match it to of spatial data of the census tracts. And so it was a little messy. So I had to wrangle that data a bit and clean it up. But once I did, I was able to join the census tract spatial data in QGIS to the tabular data shown here using my selected CSV of census tracts. I then exported that data as a GeoJSON and read it into the coding program that we were using, Visual Studio Code, as a JavaScript file, and used the program Leaflet to create a more pretty map of this data you will see soon. And so a little bit of a limitation on that, the data up until 2019 was good and complete for most of the census tracts. However, in 2020, I only had about a third of the census tracts that I wanted. So I really would like to get some more current data. However, the data just wasn't there. So I had to limit my data in that respect. And then the other map, the raster data, for the satellite imagery land use map, I created a code using Google Earth Engine where I could select a certain part of the US, Atlanta, and create this geometry and then find the satellite imagery for that data, for that area of certain years. And I was also limited further in this respect because Atlanta wasn't imaged each year. It was only imaged 5 times in the period of years that I wanted to look at. That is 2010, 2013, 15, 17, and 19. So I only had 5 images to work with. Additionally, I ran into another problem where the color bands were not the same in all of the images. So you can see here the 2010 image versus the 2017 image. It looks like it's getting greener, but it's really not. So the urban area was actually expanding. However, the color bands were greener, and that could be due to the technology used in certain years and how that was updated. However, I needed a way to normalize this to just see the urban area and the vegetation, so I applied a grayscale using QGIS so that you could just see black as vegetation and white as urban data. So my final geovisualization, it's a web-based geovisualization, the website that I coded, so I'll pull that up. So here it is, displaying urbanization and sprawl in Atlanta metro area census tracts. So here you can see my 2 different map elements. They are interactive, which is something that I wanted to portray in my website. So here, if you use this slider, you can see the year and the data, and you can see it changing. So it's a choropleth map of population density data by census tract. The darker areas are more dense, and the lighter areas are less dense. And then on the right, you see satellite imagery of Atlanta physical urban growth. These are my images from Google Earth Engine, and I created buttons so that you could toggle through those as well and see the urban area expanding. And while these aren't perfectly colorized, it does do a great job of showing non-urban area versus urban area. And you can especially see that change from 2010 to 2019 and how much that has expanded on the right. So what I really wanted to explore was the correlation between the 2 maps. So we can see that trends on the map on the left, that most of the census tracts are becoming more dense, but that is because many people are moving into Atlanta still. It's still a growing city. And so most of these census tracts are still growing. However, there are some census tracts in the center, in the city center, kind of around here, that are becoming less dense from 2010 to 2019. You can kind of see the difference there. And something that is of more interest is the outer census tracts. You can kind of zoom out a bit on that and see how those are actually increasing in density, which correlates with the map on the right of these urban areas growing kind of towards the outer ends of the city and the suburbs. Points of interest especially are this kind of Sandy Springs, Brookhaven area, which is where I'm from. And you can see how this density in 2010 is becoming a lot more dense in 2019. It's getting darker over there. And that correlates with this built environment on the right, where you can see that that built environment is actually expanding. So that is my visualization. Oh, I'm so sorry. So some strengths of this were my achievement of my original goals to show both vector and raster data in conjunction with one another and see how the population density and urban sprawl data correlated and also changed over time. I was also proud of my ability to make both maps interactive, both in themselves and also collectively, how when you change one map, it also changes the other. Overall website flow, I was also proud of. If anyone has ever coded before, you know how difficult it is to code a website from scratch and additionally style it using CSS. It's a lot of trial and error, and many hours were spent making this seemingly simple website. Some opportunities for improvement. I really wish that I had more data available to me. The vector data being incomplete after 2019 was a bit of an issue that I wish I had a little bit more current data, and that was added to by the fact that the raster data was inconsistently collected. It wasn't all of the years that I wanted to study, so I wish that I had more data, but there wasn't as much that I can do about that. However, it is really interesting to see that there is so much change just in that period of 9 years, and how quickly Atlanta has grown just in that period of a decade. Another room for improvement, I would really like to have some pop-ups on my vector map to show what the census tract is and the actual number of how dense each census tract was. Some solutions that I would think of for this, urban sprawl as a whole would to create more mixed-use development in the city centers. Also thinking about making more walkable cities, putting bike lanes in wherever possible, maintaining green spaces that exist, and additionally trying to make city centers more inviting and not as dangerous. Atlanta is becoming more dangerous each and every day. So all of these elements combined can reduce urban sprawl, and additionally not paving over existing green space, but instead changing existing structures to be more mixed use and mixed development would be some solutions to urban sprawl. So before I leave, a little bit of self-promotion. I will be graduating UNC Chapel Hill this May, and if you like what you see or if you think you'd like me, I will be looking for a job in the fall. So I thought I might use this platform to just promote that a little bit. There's my email and phone number, or you can come talk to me after if you'd like. Here are my sources, and I will take feedback from you. Thank you. Of course.
So just my question. So to do that programming, how long did you learn programming? Just from that one course, or did you?
Yeah, I've taken a few courses in coding in a few different programs. I started taking GIS courses in my junior year, so I've really only been doing GIS and coding for about 2 years. So I'm still very new to the study and learning as much as I can each and every day. But I think that I was able to learn a lot, especially in that class. I had a great professor. He was very helpful, helped me even spiff up my website a little bit more before I came here, even though I'm not in his class anymore. So I was really thankful to him for that. But I'm still very new to it all, so I'm learning more and would like to even improve this website even more in the future.
What platform are the maps running on, the data in the background?
Yeah, they're using Leaflet, which is a program through, I'm honestly not sure what Leaflet is run through, but that is the program that I use to run the map program, and it's Visual Studio Code that I was coding in, which I believe is a Microsoft platform.
Thanks. And have you considered using something like Landsat satellite imagery for that? Because with Landsat, you can find the exact same day on the next year, and if they have, as long as you can find days without cloud cover, you can find a lot of imagery just to accommodate like yearly imageries, and then you can do raster.
That is something I'd like to consider in the future. We had learned, what do you say? Okay, I think I've used Landsat in a different project that I was working on, but I honestly didn't think about that. We were learning the Google Earth engine, and so that was kind of in my head and what I was limited to for that class at least. Yes, I've used that before actually. It's really interesting. I've used that in different projects. It's really, really cool.
Mm-hmm. That area photo, right? So how did you do that classification? Did you just rely on RGB color values? Or
yeah, so that wasn't the most technical way that I probably could have done that. On QGIS, which is a platform that I've learned in the past, there's a way to kind of create your pixels into just black and white. And I guess that does primarily use RGB. I would have liked to spend a little more time looking into different ways to normalize those photos, but it does create it just into the black and white pixels, which I thought was, for the purposes of this project, sufficient for just seeing the urban and non-urban area. But it is not perfect, I will say.
All right, well, thank you very much.
Thank you so much, guys.